Now we're ready to construct the NPV profile. NPV profile is a relationship between NPVs and its opportunity cost. So based on the different level of opportunity cost, we obtain different NPV values. And by having enough number of the NPV values and the opportunity cost or weighted average cost of capital, we can obtain multiple data points. And by linking these data points together, we obtain two curves. One is for project A, one is for project B. So the yellow line or the yellow curve in this graph is the NPV profile for project A. And the blue curve is for project B. Now, based on these two NPV profiles, these two curves, we can draw a straight line that is parallel to the vertical axis. So that straight line will cross with the horizontal axis and the NPV profile curves. So that will tell us at any opportunity cost or weighted average cost of capital as the discount rate for the cash flow, we have a specific NPV value for that project. So for example, early on in the table, we calculated when the weighted average cost of capital is 10%, project A has a net present value $362.41, and project B has a net present value $256.85. So we can draw a straight line at 10%, and that straight line will be parallel to the y-axis, and it crosses over with NPV profile A and NPV profile B. And there are 2 points, the straight line, which is parallel to the y-axis, and the cross with two curves, we can get the NPV value for both project A and project B. And when that straight line crosses over with project A's, the yellow curve, we have the net present value of project A at $362.41. When that straight line crosses over with the blue curve, project B, we have the NPV for project B, which is $256.85. And all these are marked in our graph. So at any other rate, for example, 18.779%, if that's the weighted average cost of capital or the discount rate for our cash flows, then we can also draw a straight line which is parallel to the y-axis, and that straight line crosses over with both NPV profiles. But because at that point, these two NPV profiles, these two curves actually cross over as well. So we'll get the one NPV value for both projects. So at 18.779% as the weighted average cost of capital, the NPV for both projects is $96.34. So that crossover point is very important in terms of differentiating which one is reliable between NPV and IRR. That's the crossover point of two NPV profile curves. And how do we know at 18.779% weighted average cost of capital, these two NPV profile will cross over? Well, early on in the table, we show you how to get that crossover point. So we calculate the difference between project A and project B's free cash flow of each year. And then we calculate the internal rate of return of this cash flow difference. That will give us 18.779%. And that will show us where is the NPV profile of A and B crossover with each other. So at that point, both NPV are the same. Now, we can also see on the graph the IRRs for both projects. So for project A, that's when the yellow curve crosses over with the x-axis, the horizontal line. So that will give us 22.791%, which is exactly the IRR of project A. Well, this makes sense because at that point, NPV is 0 for project A, which is exactly the definition of IRR, the discount rate that makes NPV value equals 0. So for project B, that's when project B's curve crossover with the horizontal axis. So that will give us 25.281%. And that's the discount rate, which makes the NPV of project B equals 0. So this is also exactly the definition of IRR, the discount rate that makes NPV equals 0. So basically the NPV profile, these two curves, we can draw a straight line and that will show us at any interest rate or weighted average cost of capital what the NPVs of these two projects are. Now, the most important part of this chapter, let's see when NPV is more reliable and when NPV is the same as IRR. Now, remember the two NPV curves cross over with each other at 18.779%. That will give us the same NPV values, which is $96.34. So we call that point the crossover point of these two NPV profile curves. Now, let's see. To the right of this crossover point, so that means the weighted average cost of capital is higher than 18.779%. So for example, let's say if it is 20%, according to NPV, which project is better if these two projects are mutually exclusive? So let's see the third straight line we draw on the graph, which is to the right of the 18.779%. So say that is the 20% weighted average cost of capital. So that straight line, which is parallel to the y-axis, crossover with both NPV profile curves. Now, which crossover point with the curves gives us a higher NPV value? Apparently, project B has a higher NPV value when the weighted average cost of capital is higher than 18.779%. We can try another weighted average cost of capital value, say 25%, it will be the same thing. So to the right of the crossover point, 18.779%, according to NPV, project B is a better project because that project gives us a higher net present value. Now, to the right of this crossover point, 18.779%, according to IRR, which project is better? Well, we can just compare the two IRRs. Project A has a 22.791% as the IRR. Project B has 25.281% as the IRR. So according to IRR, again, project B is a better project because the yield on that project is higher. Now, to the right of the crossover point, when the weighted average cost of capital is higher than 18.779%, then both NPV and the IRR said that project B is a better project because both project B's NPV is higher and IRR is higher. So to the right of the crossover point, NPV, IRR, they are consistent. No conflicts. Now, let's see to the left of this crossover point. So when the weighted average cost of capital, the discount rate, is lower than 18.779%, say 10%. According to NPV, which project is a better project? Well, let's look at the project profile. At 10%, project A's NPV is higher at $362.41, higher than project B's NPV. So to the left of the crossover point, when the weighted average cost of capital is lower than 18.779%, then NPV picks project A as a better project. Now, according to IRR, which project is better? It doesn't matter to the left or to the right of the crossover point. Project B's IRR 25.281% is always higher than Project A's IRR 22.791%. So to the left of the crossover point, so when the weighted average cost of capital is lower than 18.779%, IRR picks Project B as a better project because Project B's IRR is always higher than Project A. So in this case, when the weighted average cost of capital is lower than 18.779% to the left of the crossover point, NPV picks Project A, IRR picks Project B. Now, there is apparently a conflict between NPV and IRR. Which one should we follow? Should we follow NPV? Should we follow IRR? When there is a conflict between NPV and IRR, NPV is always a more reliable method to evaluate projects. So NPV is always a better choice. Now, to the left of the crossover point, when the weighted average cost of capital is lower than 18.779%, we should pick Project A according to NPV. So why is there a conflict between NPV and IRR? This is because both NPV and IRR are built upon some assumptions about reinvestment. So according to the table, we can see that both projects receive cash flows before the project is over. So at the end of year 1, both projects receive cash flows. At the end of year 2, year 3, both projects receive cash flows. Now, both NPV and IRR, the way we calculate them, made an implicit assumption that when we receive the cash flows, we'll be reinvesting these cash flows. So for example, let's look at Project A. At the end of year 1, we receive a $200 cash flow on Project A. So the implicit assumption of NPV is that when we receive that $200 cash flow on Project A, we will be reinvesting that cash flow at an interest rate. And that interest rate is the opportunity cost, which is the 10% weighted average cost of capital. So that is the ongoing market opportunity cost for all cash flows. At the end of the year 2, we receive a $350 cash flow from Project A. So the assumption, again, we'll be reinvesting that $350 at the ongoing market rate for opportunity cost, which is the weighted average cost of capital 10%. And the same thing applies to the third year's free cash flow, $550. We'll be reinvesting that at 10%. Now, IRR also made an implicit assumption about reinvestment rate. Now, according to IRR, at the end of year 1, when we receive that $200 cash flow, we'll be reinvesting that cash flow, that $200, at the IRR as the opportunity cost. So for Project A, that IRR is 22.791%. And the same thing applies to year 2's free cash flow, year 3's free cash flow. So 350, 550, when we receive them, we'll be reinvesting these cash flows at the IRR as the opportunity cost, which is 22.791%. Now, how long do we reinvest these free cash flows? Well, till the project is over, till the end of year 4. So both NPV and IRR made an implicit assumption about reinvestment rate. NPV assumes we'll be reinvesting at ongoing market rate for opportunity cost, which is the weighted average cost of capital, that is 10%. IRR made an implicit assumption that we'll be reinvesting these cash flows at 22.791% as the opportunity cost. Now, let me ask you this question. Which one is a unique opportunity cost or reinvestment rate for the cash flows in these projects? Is it the IRR or is it the weighted average cost of capital? Now, IRR is the unique reinvestment rate for these projects because IRR is unique for the project. And project A has a unique IRR 22.791%. If we want to reinvest our cash flows at this rate, 22.791%, we will have to find an identical project to project A. And that is less likely than we find a reinvestment rate of ongoing market rate for opportunity cost 10%, which is the rate we can find anywhere else. So the implicit assumption that these two methods made about reinvestment rate, one is more realistic than the other. So the NPV's assumption on reinvestment rate is more realistic than IRR's assumption because reinvestment rate according to IRR is more unique, is less likely to find somewhere else. And let's re-examine our NPV profile graph. So to the left of the project, that means the ongoing market rate, weighted average cost of capital, is less than the 18.779%. So when we reinvest these cash flows, is it more likely we reinvest them at 10%, or is it more likely we reinvest them at the IRR of these projects, which is 22.791% and 25.281%? Well, apparently, to the left of the crossover rate, 18.779%, it is more likely to find another project which return is about 10%. Less likely to find a project which yield 22.791% and 25.281%. So the more realistic assumption about reinvestment rate is that to the left of the crossover point, it is more likely to find a project that is yield a 10% return rather than 22.791 or 25.281%. Therefore, when the ongoing market rate is low, is about 10%, so NPV is a better or more reliable method to evaluate these projects.